Induction cooking has been an important part of European cooking for decades. This unique method of cooking uses magnetic forces to create heat. It is the safest and highly energy-saving method of cooking. In the most recent What's Cooking with the CMA webinar, we highlighted induction cooking as a trend to watch. The global induction cooktops market was valued at $18.6 billion in 2018, with a projected increase to $27.3 billion by 2025. Increasing awareness about safety has been attracting consumers all over the world to procure advanced cooking appliances. Induction cookers are energy and environmentally responsible, and functionally, they create extended countertops for small spaces and allow for easier cleanup. Make sure to explore Section 23 of our engineering standards on creating induction-compatible cookware to learn more. Traditionally, to create induction-friendly cookware, if the cookware itself is not already made of magnetic material, an expensive process must be used to attach a disc to the base to create the magnetic field. Always on the lookout for the latest in technology today, we're speaking with Impact Innovations on a unique new method to create induction-friendly cookware. Welcome, my name is Fran Groesbeck, and you're listening to What's Cooking with the Cookware Manufacturers Association. Today, we are excited to have Sascha Bernhardt, Head of Sales for Impact Innovations. In this podcast, we will explore cold spray technology, how it works, the advantages, and the recent developments that have given this application a boost. You can find out more about Impact Innovations at impact-innovations.com. That's IMPACT-INNOVATIONS.com. And the CMA, of course, at cookware.org. Hi, Sascha. Welcome to our podcast.
Hi, Fran. Thank you for the very kind introduction and having me here today.
I'm so excited. Where are you joining us from?
From Germany.
What part of Germany?
Just very close to Munich, like half an hour outside of Munich.
Wow, that's incredible. We hope to be back in Germany next year when Ambiente comes back. At least we hope.
Okay, yeah. I would be happy to welcome you here.
That would be wonderful. I really appreciate you joining us today. And we were very excited when your colleague reached out to us. This is a very important topic in our industry. I'm really excited for our members and listeners to hear more about what Impact Innovations is doing in regards to induction cookware. First, can you tell our listeners a little bit more about yourself and Impact Innovations?
Yeah, sure. My name is Sascha. I'm 42 years old, married with a 2-year-old son, and I'm experienced in sales of machinery and also other innovative technologies as semiconductors and others. I joined Impact Innovations just last year as the global head of sales because I was simply amazed by the cold spray technology and the wide areas of opportunities that come with that. To Impact Innovations, it's a very fast-growing startup and hidden champion in the cold spray technology. And that's pretty much the most innovative form of thermal spraying by just using kinetic energy without melting any metals. And we understand ourselves as an industry partner for metallic additive coatings. Impact Innovation was founded in 2010, but has already over 20 years of experience in the cold spray technology and is continuously growing. And we have here a great mixture of innovative young people and as well experienced engineers that provide an exciting work atmosphere and build a dynamic team that develop cold spray not only for R&D process, but also more and more for industrial applications. And with German engineering and always striving for our highest quality and efficiency, Impact Innovations became the technology leader for industrial applications with tailor-made industry-specific solutions as the cookware industry, for example.
Incredible. I love this idea. So my background is in coatings, and everything spray means a lot to me.
Okay.
This was very interesting to me when you originally sent me the packet of information. And I love that there is this application for cookware. And as I mentioned earlier, the market share of induction cooktops is on the rise. So what are the challenges for the cookware industry when it comes to creating induction compatible cookware?
Yeah. As you just said, induction cooktops are the most energy efficient way of cooking and has the advantage of providing immediate heat similar to gas cooktops. And most pans nowadays are made of aluminum because it's light, especially compared to heavy cast iron pans, and are also far less expensive than stainless steel pans. But aluminum has the disadvantage that it's a non-ferromagnetic material, and thus it doesn't work by itself on induction cooktops. So therefore, aluminum pans require a ferromagnetic steel plate or coating at the bottom of the pan. And most common technologies to do so are either brazed induction plates or a pressed perforated plate on the bottom side, or even a thermal coating via a flame spray process or technology.
And some of those technologies present their own issues. From my product development days, I remember we had an issue with brazed, where if it's not put on properly and any air pockets are captured, that can risk the disc separating. You also mentioned the perforated plate. If the aluminum alloy, so those perforations, the aluminum will peek through. And if that aluminum alloy isn't the right grade, you can have corrosion and other things if the pan was used in the dishwasher or such things.
Correct.
So it can not only be expensive, but it can create a lot of problems. Other problems can arise. So we just touched on a couple there, but what are the problems with the existing technologies?
Yeah, you are totally right what you just mentioned. All these technologies have in common that they face several problems, and that's mainly with heat transfer or with corrosion. And especially with fixed plates, independent of a brazed or a pressed one, you always have a very inflexible process with a risk of cracks or even loosening of a plate during usage. And but even the more flexible process, like flame spraying, for example, faces lots of issues with a bad heat transfer due to melting the metals for the coated layer. You simply include lots of oxides in this layer, and this high oxide contents in the coating work as a kind of a thermal insulation or a barrier to the heat transfer. And this cannot be really avoided, as the metal must be melted for the coating process. And supplementary, the flame spray process is very inefficient because you have very high material losses during the spray process, as the spray spot is very wide and it's difficult to control it. So you spray lots of or major parts of a metal next to the pen and not on top of the pen.
Well, this leads us to what Impact Innovations is doing. And what I love is you're doing what is the biggest trend right now. You're not just providing a product or a service, you're solving a problem. So what are the advantages of this cold spray technology?
First of all, the cold spray process is very flexible, as you can spray pretty much each size and shape of a pen, even if it's not a round but a rectangular shape. But not only that, by adjusting the thickness of a coating layer, you can also control the maximum induced power according to your needs. This way you can simply distinguish between even low cost and high end pens with the same process and control it simply by your costs, the cost by the thickness of your layer. And this makes the cold spray process very competitive versus all other technologies. Besides, the cold spray process avoids any oxidation in the coating layer and thus guarantees the best possible heat transfer. At the same time, we achieve the best possible bonding of a coating layer compared to all other technologies. Supplementary to the spray spot that is very narrow and this way easy to control without wasting any material. This means, for example, we have a deposition efficiency of more than 95% of sprayed metal. And compared to other thermal spray process with efficiency usually below 50%, that's really a huge step. And in other words, we consume only about half of the raw material and achieve far superior heat transfer. And last but not least, the cold spray process is also a very green technology because it's very energy efficient, as we don't need huge energy to heat up and melt the metals.
That's incredible. And that's a very hot topic right now about being more sustainable and looking for ways to be more green, not just in, okay, the packaging is recycled or we're using recycled material in the handle. It's the whole process that the consumer wants to make sure is green. Can you
Correct. Yeah.
explain a little bit how the cold spray process works?
Yeah, the main difference between cold spray and all other thermal spray processes is that the coated metals are not melted, as I just mentioned. Cold spray uses only the high kinetic energy to accelerate metal powders or particles of the metal powders to multiple supersonic speeds. And this works by using a high pressurized nitrogen gas that is compressed up to 50 or 60 bar and heated up to about 2000 degrees Fahrenheit inside the spray gun. And by forcing the gas through a de Laval nozzle, the gas expands and gets accelerated to high speed, and at the same time it already cools down. And this way the metal powder gets, and then the metal powder gets injected right before the nozzle and gets the same acceleration as the gas, but without getting heated up by the temperature due to the very short contact time of the gas, which is only a very small fraction of a second. And with the impact of a powder particle to the substrate, the particle undergoes a plastic deformation and a kind of a cold welding process happens. This process leads to very high adhesion of a coating to the substrate and to a very dense coating with very low porosity. And the metal coatings have almost the same mechanical properties as the bulk material itself. And another positive side effect is that cold spray leads to very little thermal stress in the coating and on the substrate. In general, the coated powder stays always well below a temperature of about 200 degrees Celsius or 400 degrees Fahrenheit, and thus far below the melting point of the metals. And this avoids not only the oxides in the coating, but it also prevents thermal deformation of a pen.
Wow. It just seems to get better and better in the efficiencies and the ease of application. Does the coating require any post-treatment?
No, the coating itself doesn't require any post-treatment from the physical point of view. Even if a coated surface is already much smoother compared to other thermal spray process, but it still doesn't have a shiny appearance that you are used to from typical pens. So therefore you have several options to get a shinier appearance at the bottom of a pen. The first one is so-called surface activation. That means we flatten and compress the surface just a little bit to reduce the surface roughness. This is pretty much the lowest cost alternative because you hardly take off any of the coated material, and this means there is no waste, and the activation can be done even during the same processing step as the coating of the pen. The other alternative, that's pretty much the most common way right now, is machining at the bottom with a turning lathe. And with that process, you get the shiniest surface as known from common pens. But on the negative side, you also turn off lots of material, like what I mean, lots, like about 0.2 millimeter. That's about 8 mils of a just coated material. And therefore, it's simply a little more expensive. And then there's also a third way as something in between. And with that, by simply grinding the coated pen. And usually you have to grind off a little less material than with machining, but you still get a very shiny surface. And therefore this process gets more and more common nowadays.
Interesting. What development stage of this technology is this for the cookware industry?
Several customers, especially coming from the high-end cookware market, use this technology already for many years in Europe. But recent developments increased the efficiency of the process a lot. And that gave cold spray technology an additional boost, so that more and more manufacturers, even from the low-cost mass market, adopt the cold spray process technology to their manufacturing process. And nowadays, cold spray as a safe and robust process is well-established manufacturing technology for many industrial applications, and it outperforms our thermal spray process in quality and costs. And that is one of the reasons why it's also more commonly used even in the automotive industries, and there are several applications, for example.
Very interesting. This is incredible. It's been around for a while, and I think it might answer some questions on some of us who have seen gourmet lines in the market that promoted certain features. I think we now understand. And it's such perfect timing for our members to know about this technology. Is there any further potential in this technology?
Yes, we already did trials with customers to replace even the inner plasma coating of a pen, which is the layer underneath the anti-stick coating. And but we are still in a development stage, to be honest. And I think even far more interesting process or potential with a far higher market potential is the use of new innovative materials for the coating of the induction layer. And by using new materials, you can limit the maximum heat temperature of a pen.
Why should the temperature be limited, and how does that work?
The temperature limitation has two major advantages. First, you get a more even temperature distribution within the entire area of a pen, and thus get better cooking results. And second, you protect the pen against destruction of the inside anti-stick coating by overheating. It not only extends the lifetime of a pen, it also prevents health and fire risks. And Impact Innovations already developed such new materials that reduce magnetism above a certain temperature. And this way, the induced power gets controlled in each small area of a pen surface and provides the same temperature in the center as well as at the edges of a pen. And that is a performance where every ambitious cook is looking for.
That is a very good point. Yes, it is. That is. And we have a whole new range of cooks here in the US due to the post-COVID world we're emerging into. And I'm sure you have this in Europe. We have younger people who had to cook more for themselves because they were, doing school from home. We have people who the kitchen has become such a core of our family, work, personal life that they're really paying attention to cooking, not only as something that needs to be done, but as a hobby and escape. And they're learning that making sure their cookware works the way it should is really important. Now, we have an interesting offer that you have given to our members, which is to coat a pan for free with this technology, correct? That you would coat one sample for them. That is such a generous offer. Thank you.
You're welcome. Yeah, I guess it's important that each manufacturer can see really the performance of this coating by itself on your own pen, and it's easier to simply take a pen from a different manufacturer. So everybody is very welcome to send us a few pens, and we apply the coating according to their needs.
Excellent. And if they're interested, you sell them the equipment and the technology, and you teach them how to use it, correct?
Correct, yeah. I mean, we are machine manufacturers, so therefore we only sell the equipment. We manufacture samples or let's say very small batch sizes. And if somebody doesn't want to take the entire manufacturing process in-house, you can either outsource this to your regular supplier of a base pen, or there are also service companies that like coating shops that do nothing else than doing the coating for you.
Fantastic. Well, I really appreciate this, Sascha. This is so timely and so important for our members. And I really appreciate you joining us today.
Yeah. Thanks a lot again for having me here. It was really fun talking to you.
This is great. And I look forward to working more together. And just a reminder to our listeners, if you want to learn more about induction cooking methods and proper construction and standards, it is covered in Section 23 of the CMA's Engineering Standards, which can be purchased on our website, cookware.org. And that's a wrap for today. You've been listening to What's Cooking with the Cookware Manufacturers Association. Thank you again to Sascha of Impact Innovations for joining us today. My name is Fran Groesbeck. We're recording this podcast for the Cookware Manufacturers Association. You can find my contact information and more at our website, cookware.org. You'll find this podcast and others in the member section of the cookware.org website, as well as iTunes, iHeartRadio, CastBox, Stitcher, Google Play, and many more. At the CMA, we can't say it enough. Our members are our number one priority, and the association is a proven, valuable resource, giving our members access to our exclusive engineering standards with a long and trusted industry history since 1922, timely statistical reporting, resources for retailers, and the best members network in the industry. And of course, important information on topics critical to our industry via our podcast like this one. Stay safe, be well, and happy cooking, everyone.